All right, hey guys, welcome back to the Ozzie's podcast. Here I'm with Ileana.
Hi, how you doing?
So she's a student. She's going to be talking about her research with Ozzie and Sanctum, which is basically holly basil. So first question, can you give us an overview of the purpose of this research on Ozzie and Sanctum?
For sure, and it's a pleasure to be here. I'd love to talk about it. So the purpose of the study was to explore whether holly basil, a well-known medicinal plant, could help stop bacteria from communicating with each other. This communication is important because it allows bacteria to organize themselves, spread, and become harder to treat.
Mm-hmm.
So instead of killing bacteria directly, which often leads to antibiotic resistance, the study looked for a more subtle strategy, disabling the way bacteria talk.
Wow.
Yep. If holly basil could disrupt that, it might become a useful tool for reducing infections, especially stubborn ones, like connected to biofilms.
That sounds awesome. So what exactly is quorum sensing, and why is it considered an important target in combating bacterial infections?
Quorum sensing is the process of that bacteria uses to sense how many other bacteria are around. They kind of release small chemical signals, and the more bacteria there are, the stronger the signal becomes. When the signal gets strong enough, the whole bacterial group changes its behavior at once, almost like flipping a switch. This kind of helps them form biofilms, which are like protective slime layers. It also helps them release toxins, move together, and resist antibiotics. And if we block quorum sensing, the bacteria lose their ability to coordinate these harmful group behaviors. They're still alive, but they become much less dangerous and easier to treat.
Well, that sounds really crazy. That's crazy how you can do that. Mm-hmm. So why is Ocimum sanctum or holly basil a promising candidate for quorum sensing inhibition research?
Yeah, so holly basil has been used in traditional medicine for centuries, especially in India and Southeast Asia, because it contains many natural components with anti-inflammatory or antimicrobial effects. Scientists expected it might also have chemicals that interfere with bacterial communication. What makes it especially interesting is that it's widely available. It's relatively safe for humans, rich in bioactive compounds, and not yet fully studied for quorum sensing effects. This study helps fill that gap by testing whether holly basil can specifically block bacterial communication rather than kill bacteria outright.
Mm-hmm. Well, that's really interesting. So what pathogens were included in this study, and why were they chosen?
Awesome. Yeah, the study included both human pathogens and agricultural pathogens, which are bacteria that infect fish. So some of the major ones tested were E. coli, Pseudomonas aeruginosa, or PAO1, Proteus mirabilis, Serratia marchiensis, and several Vibrio species, which are important to fish farming. These bacteria were chosen because they are well known for forming strong biofilms, which make infections harder to treat. Many of them also cause chronic infections, like in wounds or medical devices or agricultural systems. So finding ways to weaken them could have a wide impact.
Could you describe the methods used to test the quorum sensing inhibitory activity of the extract?
Oh, definitely. We used several different lab experiments to see how extracts affect communication. The first was violacin inhibition. It's a special purple producing bacteria that makes pigment only when its quorum sensing system is active. If the color fades, communication is being blocked. The second one was biofilm measurement. We let bacteria grow with and without the plant extract, and then measured how much biofilm, or that slimy buildup, they formed. And then third, we used EPS measurement. EPS is the sticky material bacteria produces to build biofilms. Reducing EPS shows the extract is affecting biofilm construction. By comparing treated and untreated samples, we could see the extract acting specifically on communication and biofilm formation.
That's really cool. Honestly, it's so crazy how color can help you determine, the function of what exactly bacteria is doing. Mm-hmm. So going back to the how do you say violacin?
Violacin.
Violacin. Sorry.
No, you're good.
How did the violacin inhibition assay help determine quorum sensing disruption?
Definitely. So Chromobacterium violaceum produces a deep purple pigment. What we call violacin. but only when its communication system is turned on. It's like a visual yes or no signal for quorum sensing. When the holly basil extract was added, the purple color became lighter or disappeared entirely at higher concentrations. That told us that this extract was interfering with chemical signals the bacteria needed to activate pigment production. It's one of the clearest, easiest ways to see quorum sensing inhibition in real time.
Oh, that is something right there. So, what did you observe regarding biofilm biomass reduction? Reduction in the treated bacteria strains.
Yeah, so what we noticed was the holly basil extract caused a huge drop in the amount of biofilm the bacteria were able to form. In some of the bacteria, biofilm went down by over 90%, which is extremely significant. For example, the Serratia marcensis showed around a 92% reduction, and the Vibrio harvii, a major aquaculture pathogen, had almost a 98% reduction. Since biofilms protect bacteria from antibiotics and the immune system, stopping them from forming is a major step towards making infections easier to handle.
Yes, it's always a good thing trying to find different ways to treat infections. It's always amazing. It always amazes me how science is able to do this. So how did the extract affect extracellular polymetric substance production, and why is it significant?
Yeah. So EPS, that extracellular polymeric substances, is a sticky material bacteria use to build biofilms. Think of it as the glue and scaffolding that holds bacteria communities together. The extract drastically reduced EPS production. In some species, EPS dropped by 90% or more. This matters typically just because without EPS, bacteria can't form strong biofilms. They stay more exposed, they can't cling to surfaces as well, and they become more vulnerable to treatment. It's like removing the brick and cement from a building. The whole structure becomes weak.
Yeah, that makes a lot of sense. Did the Ocimum Sanctum extract show any direct antibacterial activity at the concentrations tested?
Not quite. It didn't kill them. The study confirmed that it didn't prevent them from growing. This is actually what makes it scientifically valuable.
Okay. And what methods were used to identify the activity chemical constituents of the extract?
We used gas chromatography mass spectrometry, GCMS. This technique works by separating each chemical in the extract and then identifying them based on their molecular fingerprints. GCMS revealed 16 compounds, with eugenol and acetyl-eugenol being the most abundant. These results helped narrow down which chemical might be responsible for blocking the bacterial communication.
Awesome. Going back to eugenol, what role does it play in quorum sensing inhibition based on your findings?
Yeah, for sure. Eugenol turned out to be one of the main active ingredients in holly basil extract. It's a natural compound also found in cloves, nutmeg, cinnamon, stuff like that. When eugenol was tested by itself, it showed the same ability to block the purple pigment in the testing bacteria. This told us that the eugenol is likely responsible, or at least partially responsible, for the quorum sensing inhibition seen in the whole extract. This makes eugenol a strong candidate for future research into plant-based infection control.
Awesome. And then just lastly, can you explain how the computational docking studies support eugenol's mechanism of action?
Yeah, of course. Computational docking is like using a virtual puzzle to see how a molecule fits into a bacterial receptor. In this study, a model showed the eugenol combined to the RHIR receptor in Pseudomonas aeruginosa, which is one of the key proteins bacteria use to detect communication signals. If eugenol sits in the receptor, it can block the real signal from binding, confuse the bacteria, and stop communication pathways from activating. This gives us a possible explanation for how eugenol disrupts quorum sensing at the molecular level.
Awesome. This is so awesome. It's really awesome that you can combine, this is like a mixture of microbiology and then pharmacology together. It's just so crazy. Do you think you would continue this research later on in the future?
For sure, I definitely would. So, just because there's, studies that suggest that natural plant compounds like eugenol could be developed into new tools for preventing infections, it could be used in medical devices to prevent biofilm buildup, wound treatment, water purification, and fishing farms. And because biofilms play such a huge role in chronic and hard-to-treat infections, having plant-based substances that weaken them could make a major difference in both human health and, agricultural settings and such.
All right, awesome. Thank you so much. Well, that's all my questions for today. Thank you so much for coming to the podcast, and I hope in the future you get to continue this research. This is amazing, and yeah, thank you so much.
No, thank you. It was a pleasure talking about the future.
All right, thank you.
Thank you.